So this talk is about the Hex Package Manager. And the Hex Package Manager is a package manager for the whole ecosystem. And I'm trying to make that point that it's important that it's for the languages in the community. And I'd like to start out with a quote from Joseph Lim that I really like, which he said for why he started working on Elixir. And he said, "I liked everything I saw in Erlang, but I hated the things that I didn't see." And that's one of the things that made me start working on Hex, because the package manager was one of the things that I hated, that I didn't see, and that we didn't have. And this talk is going to be mainly about Hex, but to start out, I want to talk about Mix, which is the build and the project management tool for Elixir. And Hex integrates with Mix, but it's an external application, and I'm going to show a bit about how that works later on. So with Mix, we can generate new projects, we compile our projects, we run tests for our projects, it handles our dependencies, and it can basically do anything else you can think of because it's extendable through what we call Mix tasks. And this is a Mix file, and the Mix file is located in your project directory. It defines your project, and what you see here is a very basic way of defining your project. This file ends in .exs, and that doesn't mean anything else except that it's a convention for what we call script files. And a script file is a file that is not compiled. We just run it and execute the code, so we define the My Project Mix file module at runtime. And as I said, it's loaded automatically, and in this file you can configure your project, you list your dependencies, and you can have compile options and options for other tasks here. And this is what it looks like when you define your dependencies. So here we define two dependencies, poolboy, which is a JIT dependency, and we also have the ecto dependency, for which we have not defined a way to fetch the package, to fetch the dependency, which means it's going to be treated as a Hex package, and we just specify the version requirement. So we have a bunch of tasks in Mix for handling dependencies. We have deps get, deps update, and so on. Another thing Mix does is what we call it converges the dependencies, and I'm going to talk more about this later. Basically what converging does is that we take your whole dependency tree, which is your dependencies and your dependencies, and we converge them to a set of unique applications. We also need to sort the dependencies because we have compile time dependencies because of metaprogramming. Another very exciting thing we have in Mix is what we call repeatable builds. And what we mean with repeatable build is that everyone that is using your project is going to get the exact same set of dependencies and the exact same versions of those dependencies. And we can achieve this with the Mix lock file. And to lock a dependency means that we lock it to a specific version. And every time we fetch the dependencies, we will get this version that is in the lock file. And only explicit actions by a developer will unlock a dependency. So we have, for example, deps update that will update the lock. And this is a file that you should also commit to version control so that all the developers of your project will get this file and get the exact same dependencies. We also support rebar and makefile dependencies. And they work as long as they follow OTP conventions, which most projects do, of course. And it can also fetch sub-dependencies of rebar projects. So rebar projects kind of work out of the box with Mix, and that's really great because that means we can use all of the existing great libraries that exist in the community already. So I mentioned mixed tasks earlier, and a mixed tasks is basically a module that follows this interface. It's namespace under mixed tasks, and it has a function run that takes a list of CLI arguments. And when you have this in your project or in one of your dependencies, it will be available like this as a task that you can call via mix. And two examples of libraries that makes use of this are Ecto and XRM. So Ecto is a library for building, for wrapping databases, and it's a query DSL for databases. And it has two tasks that I want to show. It's first have the Ecto gen migration task that will generate the boilerplate for a migration, for a database migration. And it will generate that in your project. We also have the Ecto migrate task that runs the migrations. Well, and EXRM is the next project that I want to talk about. And it's a library that generates OTP releases. It makes use of relics to generate the final release, but it can take the metadata that Mix provides and the OTP configs that we have in Mix and compose everything to a final release. And this is also how Hex integrates with Mix. So Hex provides tasks for publishing packages or registering a new user, adding owners to packages, and so on. And we are finally at Hex. So like I said earlier, Hex is a package manager for the Erlang ecosystem, for the whole ecosystem. And I said that because I think it's very important that it's not just for Elixir, it's for the whole ecosystem. And you can already push Erlang packages, and there are quite a few Erlang packages on Hex already. And I'm going to talk about later about how you can use Mix for your Erlang projects and other Erlang tooling that are starting to integrate with Hex. So this is the brag slide. This is the number of package downloads per month. So we started out last year in May, and last month in February this year we had almost 200,000 package downloads. So that's very exciting, and it's growing, as you can see. So that's great to see, I think. So now I'm going to talk a bit about how Hex integrates with Mix. And mainly it does that through Mix tasks. It's a standalone application, like I said, so it's not bundled with Elixir like Mix is. So when you install Elixir, you get the build tool Mix in the whole package. But Hex is installed separately. And this is kind of because Hex is much newer than Elixir. Elixir has reached 1.0, and Hex is still in the beta stages. So this is an easy way to do it. And in the future, we might bundle Hex with Elixir, or we might continue to have it separately, because it's actually working quite great still. And this is just an example of Hex tasks that we provide. So there's tasks for registering new users, publishing packages, updating your registry file, and so on. And Hex is installed as a code archive. And for those of you who don't know what a code archive is, it's a very basic thing, actually. It's just a zip file that contains Beam files and application files. And it's not an Elixir feature. It's a feature of the coder that comes with OTP. And the code archive just looks like this. So this is basically what the Hex code archive looks like. We name it for the version so that we don't have conflicting versions. We have the app file, we have all the module bean files. And when Mix starts, we load all these code archives. So we basically add them to the code load path in your home directory. And this is a really great way to extend Mix. There's one issue with code archives, though, and that is that they are one. It's an issue for Elixir because it's compiled code, and with Elixir we don't have the same binary compatibility that OTP has. So we need to make sure that we match the Elixir version with the code archive version. And to make that streamlined, we need to make sure that updating the archive is really easy. And Mix provides tasks for installing archives and so on. And we do this by having a Mix task that installs Hex. And it basically just goes to an URL and it downloads Hex, and we give the Elixir version inside the URL so that we can install a version that matches the Elixir version. And we also include all the Hex versions in the registry file, which contains all package versions. And I'm going to talk about the registry file later. So this way we can inform users when there's a new release of Hex so they can update it. And finally, it integrates with Mix through the remote converter. And the remote converter is called by the converter, which I'm going to talk about just in a moment. And to talk about that whole flow, I'm going to talk about the flow of what happens when you run the task that fetches dependencies. So the first thing we do is run the converter. And the converter traverses your dependency tree in a breadth-first fashion. As it is traversing, it is converging dependencies. And converging a dependency means that we see if they have the same application name. So then we know that we need to convert them into a single application. And we also do checks like see if they have the same SCM, so that they both use JIT, they both need to point to the same JIT repository, they need to have the same branch or tag or reference. And we try to do this converging. If the converging fails, we say that the dependency is diverging, and we inform the user, and the user can then see this error, and they can either handle it by fixing it, or they can fix it by specifying so they can fix it by defining a dependency that is overriding at the top level project. So that is one way to always get around the issue. And as we are converging down, we fetch dependencies. We fetch JIT dependencies. We're skipping Hex packages at this point because the Hex package dependency resolution is a different thing that we need to do at a later stage because it's a bit more advanced than it's using. Because we have the whole registry, we can do the dependency resolution in a much smarter way. And I'll talk about that later. And finally, we need to sort the dependencies because, as I said earlier, we have compile time dependencies between dependencies. So we need to sort them to make sure that we compile everything in the correct order. So after the Mix converter run, we have skipped the Hex packages. So then we can run the remote converter, which calls into Hex. And we call into Hex giving all the Hex packages we found during the original converter run. So it hooks into the converter. And before we can run the dependency resolution algorithm, we need to update the registry. And the registry is just it's a very simple thing. It's just a simple ETS file, which we, so it's an ETS table that we store to a file. And it just has all the packages, all the versions of those packages, and for each package version pair, we specify all the dependencies and all the version requirements on those dependencies. And it's an ETS file today because it was a very easy way to do it. We can just persist the ETS table, and it's very easy to distribute. One problem, though, is that an ETS file is not really optimized for storage. It's not optimized for space, I mean. So today we have around 500 packages and almost 2,000 versions of those packages. And this file weighs in at around 350 kilobytes and a bit over 100 kilobytes compressed. So we need to change the registry format at some point in the future because this is not going to scale in the future. And we have a few ideas for how to do that. But it's not a big problem yet because it's still only just a bit over 100 kilobytes to distribute. So after we fetch the registry, we can continue with the dependency resolution algorithm. And the dependency resolution algorithm tries to find a matching set of dependencies. So if you remember from the last slide, we have the requirements. So every package specifies the version requirements on its dependencies. So when we have those version requirements, we can run on a resolution algorithm that finds a set of dependencies that are ensured to match, or ensured to match if the requirements are correct. And we are recommending everyone to use semantic versioning, and it's not perfect because there's nothing assuring that you're not introducing breaking changes and so on, but it's been working well so far, and I think it's basically the best thing we can do. So the dependency resolution algorithm starts by getting all the Hex packages from the converger, and those are called pending requests. So pending requests are packages that we have yet to process in the resolution. We also have a list of activated packages, which are packages that we have find a version for, and that is the version that we're going to use. So at number one, we start with the packages we got from the converger run. Next step is to take the next pending request, which is the next package that we have yet to process. We find the latest version that we can use that we compare. So we basically get just the latest version. We compare that against all the activated packages requirements, and we first try the latest version, and then we try all the other versions to see if they match. If nothing matches, we're going to backtrack, which we'll get back to later. But if we do find the matching release, we activate that package. When we activate it, we add the dependencies of the package to all the pending packages, and we save the current state for backtracking. So we save the current point in the resolution so that we can go back to this place if we find an issue later on. So with this algorithm, we can find, if there is a matching set of dependencies, we're going to find it. The problem is that if you have a very huge dependency tree, this algorithm has the potential to take a very long time because it's basically trying all the different, it's going to try all the different combinations of all packages. It has a few shortcuts, so we haven't had any issues with this yet, but we're kind of testing the waters to see if this is going to work. Another problem with this algorithm was that it was very hard to find. So if there was a problem in the resolution, it's very hard to say to the user, where this problem was, because it could be any, because it could be any combination of problems. But what we found was that every time that we do a backtracking, we can say the version requirements that failed, and we print those to the user, and those are a good indication of what the user can do to fix the issue. So finally, in the deps-get process, we're going to fetch packages. We do this by doing HTTP requests to the CDN where we store the packages. We are starting to do parallel fetching of packages, which improved performance a lot, and we're caching the packages locally. So if your net is going to go down or something, we can use the packages that you have on your computer. And even before we started to doing parallel fetching, this was a lot faster than fetching by shelling out to JIT or something like that to fetch packages or to fetch dependencies. So next I'm going to talk quickly about what a package looks like when we distribute it. So this is a package tarball. So it's just an uncompressed tarball which contains a version file which we can increment if we're doing breaking changes for packages for some reason. We also have a metadata file which describes the package and a checksum for integrity. And then finally we have a compressed tarball inside which we call contents, which contains the source code of the package. And the reason we're using source code is basically because in Elixir it's very hard to do pre-compiled packages. And that is because of metaprogramming. Someone, depending on a package, can specify in their configuration something that changes the produced compiled binaries. So it's just easier to do source code. I'm going to talk a bit about ideas about doing precompiled packages later on. You can also use Hex with Erlang. We have what we call standalone mix, which is just an e-script with Elixir bundled, so you can use mix without installing Elixir. And you can use mix for your projects. Mix can compile source code for OTP applications, and you can use Elixir for configuring your application and your OTP environment. And I think that's great because Elixir, I think, is a good language for scripting and for configuration. And there's a project called Mix Erlang Tasks, which you can find on GitHub, and I believe it's also on Hex now, which extends Mix with a few tasks for testing your application. So it has common test, eUnit, and a task for generating documentation. So if you want to try out Mix with your current projects, you can check this project out, and hopefully it can help you by providing tasks for your common things that you do. I'm also going to talk a bit about Hex PM, which is what we call the API server and the website. On the website you can find documentations for packages, you can browse and find new packages, we have download statistics and so on. And we just use the API server for basically just registering new users and publishing packages. So all the registry and the packages, the package tarballs, are distributed separately, so that if the API server were to go down for some reason, we're not going to break your deploys or your workflow. And this is just what the start page for the website looks like. And like I said, we also host documentations there, so you can use Xdoc, sorry, it's supposed to say Xdoc, to generate your documentation. And to do this, you just call mix Hex Docs, which calls into the documentation generation, and then it's going to zip that up and upload it to Hex Docs, where we host your documentation. And this is and this is just an example of what that will look like. You can also do that for your Erlang project. So SBroker is a project that is distributed through Hex, and you can just call into edoc. So you can just replace the docs task that Xdoc provides with the task from, if you remember, from here. If you just use this project, you can upload documentation for your projects easily. And Mix already has support for building eScripts, but we're also going to add the support for installing eScripts globally. And eScripts are just a compiled binary with the Beam code that you can run from your shell. And if you remember from earlier, this is what it looks like to define your dependencies. And we're going to use the same format for installing eScript. So you can either go through JIT or through Hex, and it will fetch the JIT dependency or the Hex package, and will use the existing functionality for installing, for building the eScripts, and then it's going to install it somewhere on your local system where you hopefully have your path pointing to. And this functionality is going to come in the next minor release of Elixir, which is going to be 1.1. Finally, I want to talk a bit about Erlang tooling and how it can integrate with Hex. So we have Rebar 3 that is being worked on by Fred and Tristan, which is a new version of Rebar, which is still being developed, I believe, yes. And we talked to them, and they are in the process of implementing support for Hex. And we have also been talking a bit about, with the OTP team about their planned package manager. If you remember, there was a discussion on the mailing list for IDs for an OTP package manager, and we'll be talking with the OTP team and seeing kind of what we can use, if we can work together, and I think it's looking promising. The things that we showed each other was the formats, the idea for formats for metadata and so on. It's very similar to what we have today in Hex. So I think that can work great. And Rebar 3 also is looking promising. They had a requirement that I want to pre-compile packages. And like I said earlier, the current packages are just being distributed as source code because it's easier for Elixir applications. But for OTP applications, it's much less common that your compiled code is going to be different because of some kind of configuration. It's almost always exactly the same. The only thing that you need to keep in mind is that you need to pre-compile for every new major runtime version. So we're working with them, and we have a proposal for how to do pre-compiled packages, and that's looking very promising. And I think Rebar 3 can use Hex, and that's great because the goal with Hex has always been to be for the whole community, for the whole ecosystem. So the idea is to have one shared specification, and then we can have multiple clients and multiple servers that are implementing the specification. And the specification is just to share the same format for the registry. We share the same format for the package so that we have the same format for the tarballs and how they are laid out. And also the same HTTP API so that everyone can publish new packages the same way. And this is great because it means that we can still have many different build tools. We can have rebar, we can have mix, we can have build tools created by the OTP team, but they are still talking the same language when it comes to the package management. And that's great because that means we can all focus and have packages on the same place, or at least find packages in the same way. And we don't even have to have the same repository for all the packages. We don't have to have Hex PM. Hex PM can be one alternative, and then there can be curated repositories for those that like curated repositories. And so on. There can be one repository, for example, for all the applications in the OTP distribution, so that the OTP team can control. So that is the big picture of Hex, that the idea is that we can all use it in the end. Thank you. That was everything from me.